All right, so like I mentioned, we are editing that packet for Unit 3. It was split into the 2 parts, or multiple parts, but like the 2 tests. I'm going to pull up that table of contents so I can show you what I'm talking about on here. Okay, so on the front of your notes packet, we covered parts 1 through 5, and we took test A. Okay, that's what we did last week, and we've corrected and retaken already. Now, for B, what we have decided is we are not going to cover inverse trig or sum and difference IDs. Okay, what we are going to do instead of inverse trig is to lead us into solving trig equations. We are going to review quadratic equations and factoring. So that's the new paper that I handed out to y'all. So if you want to take out these from the packet and throw them away, you can, or you can just put a line through them. That's up to you. But I handed out this new one for quadratic factoring. And that's what we're going to go over today. And then tomorrow you're going to do some practice on Delta Math with it. And then we'll jump into solving trig equations. But before we can solve trig equations, you have to be able to solve regular equations. That's why you did the linear equation practice last week on Delta Math. And now we're going to practice with quadratic. And then we'll get into the actual trig equations. Okay, so remember, quadratics are functions when you have x squared. Okay, remember they make the shape of a parabola when they're graphed. Okay, this is our standard form, ax squared plus bx plus c. Okay, if you were asked to actually solve the quadratic, you set it equal to 0 and then factor to solve. Now, if you can't factor, you use quadratic formula, but we're not going to have any, we're practicing factoring. So I'm going to give you ones that can be factored, okay? You're not going to have to worry about going back and doing quadratic formula, but that's how you learned it in Algebra 2. When something was not factorable, then you did quadratic formula to solve, okay? So there are some different types of factoring, though, that we need to review. I've been having everybody kind of try these as a warm-up. I had y'all try those earlier, so hopefully you were able to do maybe a couple of those. Before I jump into going over those, I want to talk about, though, those different forms or different types of factoring. All right, so greatest common factor. Okay, so your greatest common factor, that's when you take out something that both terms or all terms in your expression have in common, something that they can all be divided by. Okay, and that what you divide out, what you pull out, for some reason my pen's not working, so I'm going to try and reload this, is called the greatest common factor, and then you put in parentheses what's left. Still not working. Let me try plugging in. So in those examples here, number 1 is a greatest common factor problem. Okay, we want to know, what do those terms, 34x to the 4th y cubed and 17x squared y to the 5th, what do those have in common? Okay, what can both of those be divided by? Okay, so for numbers, it would be 17. What about the variables? Yeah, so if you look at, they both have x, but the highest power that they both have is squared, and then they both have y, and the highest power would be cubed. So you could take out a 17 x squared y cubed. All right, my pen is not working, so I'm trying to write this with my mouse. Try and be as neat as I can. Okay, so that's the GCF. And that goes outside a set of parentheses, and then inside is what's left. Okay, so that is the actual greatest common factor. Okay, and then we're going to put here what's left. Okay, so when I say what's left, I mean, what do you get? What's remaining in that expression after you divide that GCF out? Okay, so when I do 34 divided by 17, I get 2. When I do x to the 4th divided by x squared, that's x squared. Y cubed divided by y cubed, that reduces to a 1. So I don't have to write times 1. Okay, and then minus 17 over 17, that's a 1. X squared over x squared, that's a 1. Y to the 5th over y cubed, that's y squared. Okay, so that's an example of GCF, greatest common factor. We were actually already doing greatest common factor on that last test on some of the where we were verifying the identities or simplifying the expressions using identities. A lot of sometimes the algebraic step in between was doing a greatest common factor. You good with that one? Okay, now the other three, the next three types here, grouping, box method, and slide divide, those are all options for when you have a trinomial in quadratic form. Okay, so all three of these can be used for a quadratic or a trinomial in quadratic form. Now, when I say quadratic in trinomial, sorry, I'm trying to see if my pen will work now. Oh, yes, finally. Okay. Okay, so all of these can be used. It's not working great. It keeps putting all these extra lines, but I guess it's better than not working at all. Okay, so it can be used for trinomials. Bless you. In quadratic form. Okay, so again, when I say in quadratic form, I'm talking about where you have, so trinomial means 3 terms. Okay, so we'll go back here. Ax squared plus bx plus c. The x squared and the x, notice the power on the x is an understood 1. Okay, so as long as this term's power is half of this variable's power, okay, and then the last term is a constant, no variable, then that is considered quadratic form, trinomial. Okay, so as long as it's in that format, we can use one of those methods. Okay, so out of these examples, that would be numbers 2, 5, and 6 for sure. Those are all with an understood A value of 1. Okay, number 4 is also in that format, but the A value is not a 1. Okay, so this is 4 is where those really come in helpful, having those methods. Okay, so we're going to review those methods before we come back and have you try number 4 here. 2, 5, and 6, these are all quadratic form trinomials for sure. Okay, you can see the power 4 and 2, okay, that, and then a constant, and then the power 6, and then 3, and then constant. Okay, but when your A value is an understood 1, you don't actually have to go through one of those methods. Sometimes it's easier just to think about the factors of your lead term. Okay, so the factors of x squared are just going to be x. Okay, and that should match this middle term, this b term, so x. So these are x terms. Okay, and then you're asking yourself, what multiplies to give me the c value there, negative 48 in this case, but adds to give me my b value, which is 2. If you need to, write out the factors of 48. So that could be 1 and 48, could be 2 and 24, 3 and 16, 4 and 12, 6 and 8. Okay, so those are all different factors of 48. Now let's pay attention to the sign, okay, the positive or negative value. Okay, we need it to multiply to a negative. So doesn't that mean one has to be positive and one has to be negative? Okay, now which of these numbers would combine by addition or subtraction to give me the 2? 6 and 8. Okay, which one needs to be the positive and which one needs to be the negative for this to come out to positive 2? Now you could have written x minus 6 and then x plus 8. The order of those two factors doesn't matter. Is that coming back to y'all a little bit? Remember that? Okay, so you're doing the same thing with 5 and 6. Okay, except it's not x as the beginning of each binomial. In this case, it's x squared. And in this case, it's x cubed. But you're still looking at your C value and asking what multiplies to give me that value, negative 16, but adds to give me the B value. Now in this one, if it multiplies to give me a negative, again, I know one has to be positive and one has to be negative. And on number 6, it multiplies to be a positive. So that means that the signs have to be the same. And on this one, you want them to multiply to a positive, but add to a negative. So what do you know about the signs over here? It would both have to be negative. Good. A negative times a negative will give you a positive. But when you add a negative and a negative, you get a negative. Okay, so has anybody figured out what numbers 5 and 6, 5 or 6 would need to be? What'd you get? All right, so 8 and 2 here. So 8 times negative 2 is negative 16, and 8 minus 2 is 6. So that works here. Remember, this factoring is like the opposite of FOIL or double distributing. You could always check by distributing this all out, FOILing it out, and seeing if it gets you back to that trinomial. Okay, what about number 6? What would those have to be? 2 and 5, both negative. Good. Okay, so 2, 5, and 6, not too difficult because the A value, the coefficient in front of the first term, is an understood 1. Okay, where it gets more complicated is like with number 4, when there is a number there. Okay, so that's where those methods are going to come in handy. The grouping, the box method, slide divide. So we're going to review those methods and then you'll be able to come back and try number 4. Now, number 3 is not a trinomial. Okay, we actually have 4 terms here. Okay, so grouping is not only for quadratic trinomials, quadratic form trinomials. Grouping can be used when you have 4 terms like this. We can try grouping. Okay, so if I create 2 groups with these parentheses here, I put the first 2 terms together and the second 2 terms together. When I do grouping, I look at the first group I created and ask myself, is there a greatest common factor here? So is there a greatest common factor between these 2 points? What are they? Okay, 4 would be the number, and what about the variable? Y squared. Okay, and what would be left if I divided this by 4y squared? What would be left here for this term? 7y, and then I have a plus, and then that would be 4. Good. Now you look at the next group. Say, okay, this group, what is the GCF here? -3. And if I divided by -3, that would leave me with 7y. What's -12 divided by -3? +4. Okay, that's what should happen when you're factoring by grouping. Those two sets of in parentheses, what's left after you take out the GCFs, those should come out the same. That's how I knew I needed to take out the negative. If I had not taken out the negative and just the 3, it would have been -7y minus 4. It wouldn't have matched. So that's how sometimes you'll see, am I supposed to take out the negative or not? You need to do whatever to make these match. Okay, so that means 7y plus 4 is a factor. And then what you took out, the GCFs go together to create the other factor. So 4y squared minus 3. So that is the factored form for number 3. Now feel okay about that? Do y'all kind of remember grouping? Okay. So again, this is all review. You've learned these methods before. Maybe not all of them, but you've learned at least one method for factoring these. Okay, so it's important. We have to be able to do greatest common factor, grouping box method or slide divide, and then also difference of two squares for some problems. What does difference mean? Subtraction, okay, and 2 means there's two terms, and then squares means perfect squares. So it could be something like x squared minus 81. That is the difference of two perfect squares. Okay, that is a special type of factoring where you just have to take this, since both of them are perfect squares, you just have to take the square root of each term. Okay, so the square root of x squared would just be x, right? And the square root of 81 would be 9. The only difference is one is positive and one is negative. Because we need it to multiply to a negative 81, you need to make sure you do 1 plus and 1 minus. Okay? When you have the difference of two perfect squares, that will always work. You good with that one? Does that look familiar? Okay. So with number 1 on the back, on the examples, I'm going to go through all 3 methods. I'm going to show grouping, box method, slide divide. And then you get to pick which of those methods makes the most sense to me or looks the easiest or I like the best. Okay, and that's what you can use. You do not have to be able to do all of the methods. You need to be able to do one of them. Okay, you need to be able to factor. Now, before I can factor this, okay, I'm trying to solve for x. I have to set this equal to 0. Okay, because I'm looking for the zeros or the roots or the solutions, the x-intercepts, all those words there, those all mean the same thing. Okay, but I need to get all of my terms to one side set equal to 0. Okay, so I like to have my lead term positive. So I'm gonna leave the 2x squared as is. Now to move the 13x to the left side, I would have to subtract it, right? So that's gonna become minus 13x. And then to move that negative 20, I would have to add it. So that becomes plus 20. So now I've got everything to one side set equal to 0. Okay, so I'm going to do 3 different methods for this same problem. So if you're going to write all 3 down, you may want to make sure you're writing not too big. All right, so by grouping. Okay, so the first thing I'm going to do if I'm trying to solve this by grouping, and let me label A, B, and C. So A is 2, B is negative 13, C is 20. So the first thing I'm going to do is an ACB table. Okay, I'm going to multiply A times C. So 2 times 20 is 40. Now B is negative 13. So I'm asking myself what multiplies to 40 but adds to negative 13. And y'all think of factors of 40 that would add to negative 13. 5 and 8. Okay, but if I want it to add to negative, what would both of them have to be? Negative 5 and negative 8. Okay, because negative 5 times negative 8 would be positive 40, and negative 5 plus negative 8 would be negative 13. Now, some of you, when you originally learned looking for these numbers, you learned it, I don't know what it was called, like X method or something, and you put like 40 and negative 13 like this. Does that look familiar? Okay, so if you learned it with this little chart, that's fine, use it. Okay, but you're still finding the same numbers. You're asking yourself what multiplies to 40, adds to negative 13, and it's negative 5 and negative 8. I don't care how you organize your information, but you're having to find that negative 5 and negative 8. Does that make sense? Now, for grouping, what we do with that is we are replacing that B term. Okay, so I still got the 2x squared. But instead of minus 13x, I'm going to replace it with minus 5x minus 8x. Or minus 8x minus 5x. It doesn't matter which order you put them in. And then you still got the plus 20. So I made that substitution right there. Everybody good with that? Okay, now grouping, I create two groups. So with the first group, what is the GCF between 2x squared and negative 5x? What do they have in common? Not a 2, because this is 5, so just x. Okay, what's going to be left if I divide an x out of that? Good. Now the second group, what do those have in common? 4. Now let's think about this. If I just divide out a 4, this is going to be negative x plus 5, right? Or excuse me, negative 2x plus 5. Is that the signs I want it to be? No. So I'm going to divide out negative 4 so that this then becomes positive 2x minus 5, because those need to match. So 2x minus 5 is a factor. And then the GCFs that we took out go together. X minus 4 is another factor. Does that make sense? So that is factoring by grouping. Now, box method is very similar. It's just a different organization. It's putting it in like a box in a table. Okay, so if you did box method, okay, you would start out the same, doing your ACB table, figuring out what that step is the same no matter which method. You always have to start with A times C. Okay, so I do the ACB table, however you want to write that. And it comes out to negative 5 and negative 8. So now I have, make a box. Okay, 2 by 2. And I put all the terms in there. Okay, so I had the 2x squared. And I had the plus 20. Those terms didn't change. It's those new terms in the middle that I came up with. I'm replacing the negative 13x with negative 5x, negative 8x. It doesn't matter out of those two which you put where. They're interchangeable. Now what we're going to do is greatest common factor of every row and every column. So in this first column, okay, what do the 2x squared and negative 8x have in common? Okay, so I'm factoring out a 2x. What about in this column? What does negative 5x and 20 have in common? Now, if the lead term there is negative, go ahead and factor out the negative. So negative 5. Okay, and what about here? This row, what do these have in common? Just x. What about this row? And that lead term's negative, so I'm going to put negative 4. Okay. So what I factored out are my factors. So 2x minus 5 and x minus 4. And when I said it didn't matter where you put the negative 8x and negative 5x, they could have switched. If they switched, it would just switch. Your x minus 4 would have come out up here and your 2x minus 5 here. But like I said, it doesn't matter what order you put your factors. We got the same answer, didn't we? Okay. And last but not least would be, I don't know how many taught this method, were taught this method, but it's called slide, divide, bottoms up. Okay, so we have our equation. The step 1 is slide. You slide your A value to the end and it gets multiplied by C. A times C. So that becomes 2x squared minus 13x plus 40. Good? Oh, I'm sorry. I slid the 2. The 2's not there. Okay, so you slide the 2, slide the A, multiply it by C. Now it becomes simple, a simpler problem like those we were doing on the front, where the A value is an understood 1. So you just ask yourself what multiplies to 40 but adds to negative 13 is the x squared factors to x times x. So you ask yourself what multiplies to 40 adds to negative 13 and you get negative 8 and negative 5. So far, so good? Now, that's not our answer. It's not factored here because we slid that A down, okay, and multiplied it by C. So now we have to divide the A back out. Okay, so we did slide. Now we're going to do the divide, and it's dividing by A. Both of these get divided by A, which is 2. Now, if it divides evenly, you have your factor. So this is x minus 4. Because 8 divided by 2 is 4. But if it doesn't divide evenly, which 5 divided by 2, that's a decimal, right? You take that denominator and you move it up to a coefficient in front of the variable. So that's then 2x minus 5. That's the bottoms up step. Oh my gosh, this pen is going to drive me nuts, y'all. All right, so slide divide, bottoms up, box method, grouping, we all got the same factors, right? Now, the problem actually says solve. Okay, so factoring is the first step, and well, the first step was to set it equal to 0. Factoring was the next step. Now, to actually solve whatever method you chose, you got your factors. Now, those factors all have to be set equal to 0. I know. The rest are not going to have this much writing. It's just because we're doing all 3 methods here. Okay, so when you get it factored, it's set equal to 0. You split and solve. However many factors you have, you set each one of those factors equal to 0 individually. So x minus 4 equals 0. You just add the 4 over. That's x equals 4. Okay, here you would have to add the 5 over and then divide by 2. So you end up with 5 halves. So we got 2 solutions. So there's 2 places where this parabola would cross the x-axis. There's 2 x-intercepts. Remember, you can always check your answers, check your solutions by going back up to the original. Like if I plugged a 4 in here, okay, 4 squared is 16 times 2 is 32. 4 times 13 is 52 minus 20, that's 32. So 32 does indeed equal 32. So when you get your values, if you plug them back up in here, the left needs to equal the right. Okay, so you can check your answers, check your solutions that way. Does that make sense? Okay, so how many of y'all learned it factoring by grouping? How many of y'all, that was the method you remember learning? Okay. Box method? Okay. Now, did anybody learn that slide divide one? No? Okay. All right, so I don't care which of these you use. I prefer grouping. It's algebraically sound. It just, I don't know. I like it the best. But if you prefer a different method, that's fine. You can see it, they all work if you do them correctly. Okay, so I want you to try the other examples and then we'll check them. And then if we have time in class, go back and do that number 4 here with one of the methods that you want to try. As long as it's written from highest degree to lowest degree. If it's in this format, ax squared plus bx plus c, the lead term is this ax squared. Okay, you should have the highest degree exponent and then the next all the way down until you get to your constant. Okay, and if it's in this trinomial form, quadratic trinomial form, you can do grouping, box method, or slide divide. Okay, so those of you here in class, I'm going to freeze the projector screen and you're going to try examples 2 and 3. If you're watching this recording, you can pause and try them. I'm going to go ahead and work them out on the screen, but I'm not going to be talking because the people in class are trying to work them out. Okay, so in class people, you'll go ahead and try example 2 and 3, whichever method you prefer. Those of you watching the video, pause and then come back and check them. Remember, you got to get everything to one side first, set equal to 0. You're going to start with a times c, no matter what you do it, which method. So then you have to figure out what numbers multiply to give you the a times c, but add to give you the b. Okay, so that's what you're asking yourself. You know, a trick, let me unfreeze the screen so y'all can see this. If you are unsure of factors in a graphing calculator, mine's loading here, I'll show you. There's a little trick or shortcut for checking what the factors of a number are. If you go to y equals, say again? Yeah, that's what I'm going to show you. Okay, so in example number 2, you're looking for what multiplies to 210 but adds to 41. Okay, so in your calculator, if you don't know all the factors of 210, or it's a larger number like 210, you type in the number that you want to know the factors of, divided by x. Because you're asking, what can I divide 210 by? Okay, and then you go to your table. Okay, so it could be 1 and 210, 2 and 105, 3 and 70. You see this? So this table is a list of all your factors. Now you ignore the ones that are decimals because we're only looking at the integers. Okay, and you can scroll up and see the negatives as well. Okay, so do y'all see any combination here of factors that would add to 41? 6 and 35, good. Okay, so you can use that to help you find what the list of factors is. Okay, so it comes out to 6 and 35. Those are the numbers. Now, I'm going to freeze the screen again. I want y'all to try and go from there. Now, pay attention. This is x to the 4th and x squared, not x squared and x. So just pay attention to your exponents. Make sure you're putting the right exponents. All right, you might still be working, but I'm going to go ahead and show this because I just want to make sure we get through it. I did this by grouping. Okay, so I replaced the 41x squared with 6x squared plus 35x squared. See, that's highlighted, that substitution I made. Then I created the 2 sets of parentheses, the 2 groups, and I did GCF was x squared here. GCF was 5 here. And what was left in both was 7x squared plus 6. Now, if you rearranged this, if you wrote the 35x squared plus 6x squared, that's fine. It works that way too. Just what you factored out and what you were left with would have been reversed from this. But you still would have ended up with the same factors. Now, I know the instructions technically say solve, so they want you to now set this equal to 0 and solve, but I just want you practicing factoring for now. So you can stop here and then try, I want you to move on to try example 3. When I do want to point out something different in example 3, when you get this set equal to 0 by subtracting that 14u over, there is a GCF here. What do they all have in common? There is a GCF of a u. if you have a GCF, you need to take it out first before you do anything else. It's going to make your life much easier. Okay. So I'm going to take out the u, and that's going to leave me with 3u squared. Oh, no, sorry, that was a 5. So 3u to the 4th minus u squared minus 14. Now I have a trinomial in quadratic form, and with that, I can use box method, slide divide, grouping, whatever I so choose, okay? But just remember, at the end, when you list all your factored out, don't forget that u is going to still be there in front as one of the factors, okay? So if I did an ACB table here, it's 3 times 14, and my b is a -1. Let me label that. It's a Okay, so I'm asking myself what multiplies to give me, and it's -42, but adds to give me -1. What multiplies to -42, but adds to -1. And if you prefer to do the x like this, that's fine too. Does anybody know what it comes out to? 7 times 6 is 42. We need the 7 to be the negative if we want it to come out to -1 when we add it. Okay, so I'm just going to focus on this part right here for now. I'm just not going to forget that u is still there. I'll come back for it later. Okay, but here, for the trinomial in quadratic form, it's going to be 3u to the 4th minus 7u squared plus 6u squared, and then minus 14. So I made this substitution right here. Okay, so then I create my groups. Those have u squared in common. Would be 3u squared minus 7. Those would have 2 in common. That would be 3u squared minus 7. So that works. That came out to where those match. That's good. So that means 3u squared minus 7 is a factor, and u squared plus 2, and what? This u that was originally factored out, that's still a factor. So the factored form is here. That's complete. That's the factored form. Just don't forget, if you take out a GCF at the beginning, it's still there in your answer as a factor. Y'all feel okay about that? All right, so y'all can go back and try that number 4 at the beginning. You're gonna have some practice factoring through Delta Math tomorrow, okay? Mix. There's gonna be some, I'm gonna try and get all GCF, difference of two squares, trinomial form. I'm gonna try and do it all. But remember, if it's a trinomial form one, you get to pick. Do I want to do grouping? Do I want to do box? Do I want to do slide divide? So you'll have options there. Don't forget, if you haven't finished the linear equation practice on Delta Math, that was part 1 and part 2 from last week, you need to go back and finish those still. Those are each an individual daily grade.